Hello my dear friends, I am sure that you have done that first part of the questions on exercise 7.2. Let's continue with some more questions, maybe some more random 10 odd questions, and please you can take out your pen and paper, start noting down, because today also as we proceed I will be giving you shortcuts and some small simple formulas which may not be listed down in the textbook as theorems or formulas. So you can just get ready. I believe you're all ready for that. So shall we begin? Let's begin with question number 22. Integration by substitution. Integration of sec square 7 minus 4x. So I think that's quite simple because we can just substitute the angle here. So what we can do here is let 7 minus 4x is equal to t. So I'm using t here. It's not that every time you will use t. That's up to you. You can use different letters, differentiating both sides with respect to x7, 0 minus 4 dx with respect to x goes up. Let's just reduce some steps. So dx will be dt upon minus 4. So I will be sec square t dt upon minus 4. Now integration of sec square, actually do we have integration of sec square t? Do we have or not? Think. Actually we don't have, or we have. We have, we don't have. Very confusing with differentiation formulas. We do have, so that's I is equal to 1 minus 1 by 4 integral of sec square t with respect to t. So that for that again differentiation, what was derivative of tan x? Derivative of tan x was sec square x. That means integral of sec square x will be tan x. So we have that formula. So that's minus 1 by 4. So integral of sec square t would be definitely tan t plus c. That's how, of course, you can easily come across. Remember the formulas with integration. Okay, once you remember the formulas for differentiation, it's not so tough to remember the formulas. So that is going to be minus 1 by 4 tan of, the t value was 7 minus 4x plus c. That's our integral. Okay, let's proceed to. You can always pause the video and continue, of course. So minus 1 by 4 sine. Let's continue with 24. 2 cos x minus 3 sin x. 2 cos x minus 3 sin x upon 6 cos x plus 6 cos x plus 4 sin x with respect to x. As I always tell all of you, my dear students, my dear friends, differentiation is always very important. So with the concept of differentiation, actually we get an idea on what to substitute. So literally, like, it comes to us, it automatically comes to us, but we also can't tell you how it comes because it just comes. So that maybe because we as teachers, every year we keep on practicing, every year we keep on teaching, that's why maybe it just comes to us every time. Definitely as humans, once we go out of touch, definitely we will forget. So that's why you as students, we always tell you, practice, always keep in touch. So now with this, it's very clear that if I differentiate, because if I substitute this value, because I know what I have here, so differentiation of cos x is minus sin x, 3, you can see some relation there. So if I just substitute 3 cos x plus 2 sin x as t, so differentiation of 3 cos x is minus sin x plus 2, differentiation of sin x is cos x. Okay, I'll write here dt by dx. So that's going to be a little bit of arrangement. 2 cos x minus this one, 3 sin x with respect to x dt. So you can see that this is in the numerator, 2 cos x minus 3 sin x dx. So that's why, as I say, it just comes with practice. You'll also get to know how it happens. So please spend some time with mathematics and practice. So I is simply, this whole term is simply dt. 2 of course I'll take outside, not needed. This one, this is simply t. So this is 1 by 2 log of t plus c. So that's 1 by 2 log of t value is substituted as 3 cos x plus 2 sin x plus c. So that's our integral here. So these are generally like simple questions, simple exercises. Okay, so okay. So let's go to which one? Chalo, 29. Let's try them. 29. I is equal to integral of which function? Cot x log sin x. Again, see, this one also, the moment I wrote the question, it just came to me that what I have to substitute, because differentiation of log x is 1 by sin x. Chain rule, differentiation of sin x is cos x. So cos x by sin x is cot x. Cot x. That's what differentiation. So if you have not done differentiation, please go back and do differentiation once again, especially the simple differentiations. Okay, derivatives. So now differentiating both sides with respect to x, log of sin x is 1 by sin x. Okay, I'll write here. So derivative of sin x, chain rule, dt upon dx, something like a revision. That's what I'm just writing. Derivative of sin x is cos x by sin x dx dt. So that's cot x dx into is equal to dt. So then my I simply becomes integration of log x sin x is t. Cot x dx, this whole term is dt. So that's simply t square by 2 plus c. Such a simple formula. So t square, what to write? So I guess you can see here now. So that's simply log sin x whole square. Log sin x whole square divided by 2 plus c. Is it not clear? Is it clear? I think that's fine. Okay, I'll just write it up there also if it may not be very clear. So anyway, you can note down. So that I is t log sin x whole square divided by 2 plus c. You can leave it there also, not a big issue there. Okay, alright. Okay, in the meantime, then you can get ready with which question? Okay, 30 also, let's solve 30. Question number 30. The question says sin x plus, divided 1 plus cos x with respect to x. What can we do here? Again, differentiation of 1 plus cos x is what? 1 plus cos x. Differentiation of 1 is 0. Differentiation of cos x is minus sin x. Minus 2, it's okay. The function term is there, no problem. So, sin x, we have it there in the denominator, numerator, sorry. But, see, it's how simple it is. But yes, it becomes very simple with the concept of what? Derivatives only. It's not that it just comes directly, okay, no. So then my integral simply becomes, this is minus dt, numerator is t, so that's minus log t plus c. So that is minus log 1 plus cos x plus c minus log of 1 plus cos 6 minus log of 1 plus cos x plus c. I'll give you one formula now. Get ready to note down that. Okay, that's why as I was telling you, some formulas are not listed in the as theorems and all, so that's what I promised you, that I'll be giving you the small things, tips in other words, which will help you. So minus, you can write on minus of log a can be simply written as, that comes of course not just on its own, this comes from the theorem, the theory of concept of logarithm. So that of course, yeah, I will be very soon doing a very special video on logarithm alone. So there of course we will be learning, and then of course most of you already know class 12, 11 we have already done log. You have already done log. So then I can written as, see, minus log a is 1 by log a. So that's 1 by log a, 1 plus cos x plus c. I think the solution is correct. 1 log of 1. Sorry, I'm terribly sorry there. A power minus 1. Sorry, this is actually log of a power minus 1. You know, sometimes as humans we also get confused. That's why with the answer it was a bit awkward. Log of 1 by a minus log a is log of 1 by a. I have to end up now giving you a small proof on the theorem also. Very sorry for that. Okay, so that's I will be minus log a will be log of 1 by a, 1 plus cos x plus c. Humans, we all do some silly mistakes sometimes. Maybe the moment when we are just being slightly too overconfident and when we just take things for granted, I guess. So that was a small error on my part. Please forgive me for that. This is the formula. So that's minus log a is log of a power minus 1, that is log of 1 by a. So log of 1 by a, 1 plus cos x plus c. Fine? Okay, let's go to another question. 32, sorry, what 22? I equal to 1 by 1 plus cot x. Now here of course you'll have to do a little bit of simplification here and there. Cot x will transform in terms of cos and sine. So 1 plus cot x is cos x by sine x with respect to x. So 1 by, I'll take the LCM, sine x plus cos x divided by sine x denominator with respect to x. So that's going to be, goes up, sine x by sine x plus cos x with respect to x. Just a little bit of simplification. Now on that again we'll have to continue. So now just to solve, what I'll do is I'll multiply and divide by 2. Why? You will soon understand. Sin x plus cos x with respect to x. So 1 by 2 integral of 2 sin x I can write as sin x plus sin x. This is the reason, because I have to solve this fraction to make it possible to integrate. No, I will add and subtract cos x. That's why I needed 2 times of sin x that I could get only by multiplying and dividing, so that I can solve the fraction that is now sin x plus cos x, sin x plus cos x plus sin x minus cos x. A little bit of arrangement, divided by sin x plus cos x, of course with respect to x. This is here, okay, with respect to x. Now solving the LCM there, common LCM, with this we end up with I equal to 1 by 2 integral of 1 plus sin x minus cos x by sin x plus cos x with respect to x. It will be 1 by 2 integral of 1 with respect to x plus 1 by 2 integral of sin x minus cos x divided by sin x plus cos x with respect to x. That will be 1 by 2. I will not integrate this. I do not want to integrate it separately also. Here, instead of writing it down, what I'll do is I'll substitute maybe just at the side. I will make some substitution so that the teacher will also know what you are doing. I think that should be enough. That is, what I'll do here is only for this integral. I will substitute sin x plus cos x as t. So differentiation of sin x is cos x. Cos x is minus sin x. Dx will is equal to t. So this is what I have. So what I can do here is okay, no problem. If I want, then I can write it as minus. So minus sin x becomes plus sin x. Plus cos x becomes minus cos x. With respect to x is equal to dt. So that's going to be sin x minus cos x dx is minus dt. So I'll do that substitution here. So that's 1 by sin x plus cos x t dx sin x minus cos x into dx becomes minus dt. So that's 1 by 2 integral of 1 with respect to x minus 1 by 2 integral of 1 by t with respect to t. No problem with that. I'm not doing anything here. Okay, and then of course I'm showing what substitution am I doing also, so I don't think you should be having a big problem there. Okay, I'll rub it off. You have to be patient also, systematic also, arranged orderly. So 1, that is x, minus 1 by 2, 1 by t, is log of t plus c. We can take I1 and I2 and then solve them separately also, but I think that's fine, no? Just to save some time also. So 1 by 2x minus 1 by 2 log of, what was the substitution? Okay, sin x plus cos x plus c. I think that should do. Of course we can take 1 by 2 common, x minus log of sin x plus cos x, but what's the point there? It's all the same. Alright, chalo. Then another question, you can pick up, let's see which question can we do now. 34, let's try 34. I equal to integral of, what do we have there? Integral of root over of tan x. Root over of tan x upon sin x into cos x. Sin x into cos x with respect to x. What can we do here? Tan x, if I substitute, I'll get sec square x sin x by cos x. Is it possible to do something like that? I think slightly possible. Tan x, if I can substitute, but I'll need sec square x if I have to substitute tan x. I think we can do that. That is something like, there are definitely quite a few methods, but let's try this. That is, I will multiply and divide the denominator by cos x, no? Cos x by cos x. I'm just multiplying and dividing by cos x, so it's 1, so it's all the same. But that, I think, is really going to help me with the solution. Because with that, what happens here is, okay, I will make another arrangement, that is tan x. I will just arrange this. Okay, I'll just show you here. Sin x by cos x into cos x cos square x. Where am I going? What am I doing? You will get to see how things are planned out. Because 1 by cos x is sec x. Maybe something is there. So this is not, dx, okay, this is equal to that. So I is equal to root over of tan x divided by tan x cos square x with respect to x. So that will be no problem there. That is root over of, okay, I can solve it later on also. Root over of tan x by tan x into 1 by cos square x is sec square x. I think now I can substitute, because if I substitute tan x, as I was telling you, we need sec square x. That we have been able to manage to get. So let's see. Let tan x is equal to t. So derivative of tan x is sec square x with respect to x is equal to dt. So then my I becomes integral root over of t divided by t. This is dt. I think that can be solved. So that is t power 1 by 2. We can do it directly also, t power 1 dt, but I'm just showing the simplification to see. It's up to you. Okay, 1 by 2 minus 1 dt. Okay, now I'll rub off. So that is integral of t power minus 1 by 2 with respect to t. So that's going to be t power minus 1 by 2 plus 1 minus 1 by 2 plus 1 plus c. So that's t power 1 by 2 plus c. So that's root over of this 2 comes out, so 2 root over of t plus c. That's 2 root over of tan x plus c. I think that's it. Solution, I guess. Yeah, 2 root over of tan x plus c. So yeah, all this actually require practice. Okay, integration and all. No, there are practically no shortcuts just to solve this in one night. No, not possible. One more. Shall we try 37? Can I rub it off? You can pause the video. Okay. I equal to x cube sine tan inverse of x power 4. X cube sine tan inverse of x power 4, 1 plus x power 8, 1 plus x power 8. I think I know what to substitute, because sine, until unless this is substituted, it's quite impossible to integrate, because we don't have the chain rule here. So that means we have just one option, that is substitute this. There is not much second thought into that. Sine of theta. So we have to substitute this. But I think we will be able to solve. No problem with that. But that's something which you should understand. Okay. If it was differentiation, then no problem. We will be proceeding just with the chain rule. So that's not a very big issue. Integration, we can't do that. We know that there is no chain rule. So the only option that we have is let tan inverse x power 4 is equal to t. But once we differentiate, what is tan inverse of x? Differentiation of tan inverse of x, 1 by 1 plus x squared. So 1 by 1 plus, what is x? X power 4, x squared with respect to x dt. So that's 1 by 1 plus x power 2 power 8 dx equal to dt. I think we have it. Don't we? But of course, did we forget something? We must have just written it down. I knowingly did that. Did we forget something? But check, something is wrong here. I just wanted to see whether you would just carry on with me, or you would put a pause to your thought that, hey sir, something is wrong. Yeah, I did that. Something is wrong, isn't it? We forgot something. We are differentiating with the substituted value. We forgot something, that is the chain rule. Yes, exactly. Some of you must have pointed it out very correctly. So good. If you have done that, very good. So that's actually going to be derivative of x power 4 dt upon dx. So derivative of x power 4 is 4x cubed. So dx, I'll bring it up here. I did that on purpose, okay, because that's when we will realize certain mistakes which will keep us on our toes, careful. So I think that's fine now. So if you see x cubed by 1 plus x power 8 dx, the whole term is dt by 4. Okay, so my integral simply becomes, see how simple it becomes, integral of sine t dt upon 4. It was sine t, yes, dt upon 4. So simple. That's 1 by 4 integral of sine t is minus cos t plus c. Minus cos t plus c. So that is simply minus 1 by 4 cos t. What was the value of t? That was tan inverse of x power 4. Plus c minus. So yes, I will not lie to you, it is not very easy. It can be made easy for you by your own practice. So I would request you to please pick up your pen, solve as many questions as possible. The questions that are in the NCERT textbooks are not enough. You need to solve more. You can get it from many other textbooks. There are many textbooks. I cannot name one textbook. So there are many textbooks. You can follow those textbooks and solve. Okay. So that's it with the integration by substitution. We have another exercise, integration by substitution using trigonometric identities, which is also very important, which we will also be doing also in the next video. That we will try to brief it in just one particular video. Alright, so till then, practice well. Very soon I will be giving you the integration on the next exercise, that is integration using trigonometric identities, trigonometric substitution using trigonometric identities. Okay, alright then, take care, stay safe. See you in the next video.